Well, hey guys, we finally made it. We're on the last video of the topic, but this is going to be one of the most important ones because this is where we're going to put everything we've learned in the previous four videos and put it all together and do sequences of transformations. So these are going to be at least two transformations on the same pre-image. And this is going to be the majority of what your assessment's going to be over. So this is probably the most important of these videos and these notes section of the notes that you're going to have. So I thought it'd be a good idea to start with a table that kind of summarizes all the transformations we've discussed so far, and just some brief characteristics about them. Notice that the only one that produces a similar final image is a dilation. The others all, again, remember, produce congruent ones. This this table also shows you all the important criteria you need, okay? So I suggest this is a good way to reference these. Remember, you get to use your notes on your assessment. So go ahead, and this would be a good thing to kind of reference back to if you need a quick reference for anything. And so we're going to go ahead and go on here and start looking at some of these. Before we do that, though, when I talk about a sequence of transformations, this is like taking a pre-image, dilating it by a scale factor, and then rotating it a certain angle. Or taking a pre-image, reflecting it over an axis, and then translating it a certain amount, okay? So these are going to be multiple transformations on the same pre-image, all right? Just look at these two statements here, though, real fast. This one and this one, 1 and 2. Just note that if you do only translations, reflections, rotations, the pre-image is congruent to the final image. And if you include a dilation, it will produce a similar final image, okay? So it doesn't matter how many transformations you have in your sequence. The only way that it doesn't have a congruent final image is if you include a dilation somewhere along the line, okay? Now, before we get going here, you'll notice that sometimes order does matter and other times order does not matter. It just depends on what transformations are included in your sequence. And there's really no rhyme or reason for that, per se. It just depends on the setup and those kind of things. So don't get hung up over if it can be done one or two different ways. Some of these have multiple answers, and on your assessment, if you can represent things in more than one direction or one way, then that's okay. I'll accept it however you present, as long as it's a correct sequence. Okay, so let's go ahead and look at page 21. And our first example here, this is just a chance to give you a review of the previous page, okay? So I have some sequences of transformations here. Which ones will produce a congruent final image? Which ones will produce a similar final image, okay? We're going to do A and D here together, okay? Actually, we're going to do A and C together, my mistake. And then I'm going to leave B and D for you to do on your own. You can check the answer key on Canvas, okay? So for example 1A, you have a vertical translation and then a dilation by a scale factor of 3. Well, the key word here is dilation. We know that anytime we see that word, it produces a similar final image. So because dilation is in the sequence, the final image will be similar to the pre-image, okay? So that one's for A, and we're going to do C also. And then for C, okay, we have a vertical reflection, a diagonal translation, and a 180-degree rotation. So dilation is not a part of that sequence, so then I will conclude that the final image will be congruent to the pre-image, all right? So B and D are yours to do on your own. Go ahead and check those out when you get a chance to. We're going to go ahead and take a look at example 2, okay? And again, I'm going to do one of these right now with you, and then I'm going to leave you the other one to do on your own. So you have chances to practice some of these and without assistance from me, and you can check your answers again on the answer key that's posted on Canvas, okay? So I'm going to do actually problem A, and you're going to do problem B. All right. So in each case, it says describe a sequence of two transformations that transforms figure 1 into figure 2. Okay. And here's the thing with these, since these are out in space, not on the coordinate plane, we're not going to be specific about the descriptions, okay, so much. We'll say, like, for example, for figure 1, we could say, vertical translation or horizontal reflection or 90-degree rotation, okay? Or a dilation that enlarges, stuff like that. I'm to be like, we're not going to assign we're not going to assign specific numbers to these because we don't have any specific numbers to assign, okay? So we're going to keep the descriptions pretty generalized here, pretty general. And we're going to start with A. So on A, it's a little misleading, okay, because we talked about rotations before, so you can't fall for the trap on this one either. But there are two transformations here, and if you do the rotations as I've suggested by actually physically turning your iPad or your paper, you would realize that this actually is a rotation, because you see the point here, so you figure it's probably a rotation. But it's actually a rotation going around this way, counterclockwise, instead of it being clockwise. Okay? If it was clockwise, the arrow over here would be facing there instead of facing the other way. That's not happening. Okay? So the first transformation is a 90-degree counterclockwise rotation. Now, I was specific on this one just because we know it was a quarter turn, and that's 90 degrees. So, again, we're not going to talk about the next one, of course, if you can tell, it's a translation. So, we don't know how much. So, we're just going to say translation right. Okay? Because we don't know how many units right it happened. We do know that it happened this way. Okay, so there's transformation 2, transformation 1. Okay? So I want you to do something similar, and it's also similar, catch that, to a problem B, okay, and try to get the description of the transformations that you see, all right? Now, on example 3, okay, and in example 4, we're going to do these on the coordinate plane, okay? Now, here is a suggestion for doing these transformations on the coordinate plane. Okay? The suggestion is to do these in sequence, but as you do them, okay, get the coordinates of each image after you transformed it. So, for example, if you notice here on example 3, okay, we're going to rotate the figure and then we're going to reflect it. So what we're going to do is we're going to get the coordinates of the image after we rotate, and then we'll take those coordinates and reflect them, and then we'll be able to get the final coordinates of the final image, okay? And notice, okay, that each time we add a transformation, we change our prime notation. So if you notice right here on part B, it's A prime, B prime, C prime, D prime, and then on part C, it's what we call A double prime, B double prime, C double prime, D double prime, okay? So each transformation we add to the sequence adds an apostrophe to the end, okay? So keep that in mind as you do this as well. So we're going to go ahead and plot the points of this rectangle, okay? So we'll do that over here on the plane. Negative 1, 1 is right here. Okay, negative 4, 1, right there. Negative 4, 5, 2, 3, 4, 5, it's right there. And then negative 1, 5 is there. So go ahead and get the rectangle. I didn't want to cooperate there for a minute. Okay, so I have A, And we're going to go around this way, B, C, and D. Okay, so now I'm ready to start my first rotation. Okay, the first transformation, which is a rotation. We're going to rotate 90 degrees clockwise. Remember, clockwise is this way. Okay, so take your paper or take your iPad, rotate a counter or a quarter turn clockwise. Okay, write down the coordinates of A, B, C, D on your paper, scrap paper, wherever, and then put your iPad back in normal position and plot them on the graph accordingly. If you were to do that, you would find that these are going to be at these points. A would be at the point 1, 1. Okay. B would be at the point 1, 4. C would be at the point 5, 4. 2, 3, 4, 5. 1, 2, 3, 4. And D would be at the point 5, 1. Okay, just like that. So connect these together. Oh, that one needs to be done again. Better. Excellent. Okay, so there's A prime. Okay, and here is B prime, and C prime, and D prime. And we're going to go ahead and get these down here in our spaces so we can map this out. So that A prime is 1, 1, B prime is 1, 4, C prime is 5, 4, and D prime is 5, 1. Okay? Now here's what happens. In order to do the next transformation, the red image, A prime, B prime, C prime, D prime, becomes the pre-image for the next transformation. So we're going to apply the reflection on the red rectangle, the prime rectangle. Okay? So let's mark our axis. We're going to reflect over the x-axis. So we'll mark that just like so. There we go. And we'll go ahead now and reflect the rectangle. So A prime is 1 level above, so A double prime is going to be 1 level below. B is 4 levels above, so it's going to be 4 levels below. C is 4 levels below. D is 1 level below. So connect, 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 connect. A double prime, B double prime, C double prime, D double prime. Okay? And then we can get our coordinates. So A double prime is 1, negative 1. Okay? B double prime is 1, negative 4. C double prime is 5, negative 4. And D double prime is 5, negative 1. Okay? So we did 2 transformations in the original image, the blue image. We just did it in sequence. We did it one at a time. So that's all you're going to have to do is just do multiple transformations on the same pre-image. And that's exactly what this is all about. You just got to do it in order and just do it by parts. Okay? And that way you'll preserve your accuracy and make sure that you have a final complete image. All right? Let's look at example 4. Now, on example 4, I'm going to get you started on this, but I'm going to let you finish it some too. We're going to talk about what the transformations are, but I'm actually not going to do a lot of plotting on here on this one. I want you to try this one on your own. Okay? So I'm just going to plot the pre-image and talk about the transformations you have to do, and then you're going to be able to do them. And you can check your answers on the answer key on Canvas, okay, and see if you are correct. That way you get some practice with this, because these are going to be more like your test questions you're going to see on your assessment. So I want to make sure you got plenty of practice on these. So we're going to plot the pre-image. 1, 2, 3, 4, 0, right there. Okay, 2, 4. 1, 2, 3, 4, right there. And then 6, 2. 1, 2, 3, 4, 5, 6, 1, 2. There's our pre-image. Okay, so there's that side, that side, that side. Then there's A and B and C. All right, so take a look at these real quick, and I'm going to pause for a minute, and you're going to tell me, or you're going to be able to tell yourself exactly which each of these transformations is using the symbolic representation. So I'm going to pause for a minute, and then we're going to talk about which one each one of these is, each transformation described here. So I'm going to pause. Okay, so I am going to tell you that B is a dilation. Scale factor is 1/2. You can see it right here. 1/2 there, 1/2 there. Okay, and C here is a translation because you see the x plus 2 and you see the y minus 3. Okay, so all you have to do is dilate by a scale factor of 1/2 and then translate those points accordingly. And you can check your answer in Canvas, okay, on that one. On our last one, now again, we've had problems like this as our final problem for almost all the topics, so all the lessons so far on this topic. So why not end it this way as well, to keep the tradition going? So what we're going to do is I'm going to get you started on each one of these, and you're going to finish it, okay? So what we need to figure out here on this is I'm telling you there are 2 transformations on each figure 1 to get figure 2, all right? So you have to figure out what those 2 are. And I'm going to help you with the first one in each case, and then from that you can get the second one in each case, okay? So again, this is all about comparing your order pairs, A to A prime, B to B prime, and so on and so on. Or in this case, A to A double prime, because remember there's more than one transformation involved here. Okay, so there's A and there's A double prime. So looking at A and A double prime, it looks like definitely a reflection going on here along the y-axis, I believe. Okay, so definitely reflection there. I'm gonna fix that line so it's not as big. There we go. Okay, so that to me is going to be the first transformation here in this sequence, because look at where B is on the pre-image right here, and look where B prime is. They're farthest apart from each other, and the only way that can happen is if the pre-image was flipped. Okay, so the first transformation involved here must be a reflection on the y-axis. So I'm going to actually draw in the A triangle A prime, B prime, C prime for you, and then from there I'm going to let you finish it up and tell me what and tell yourself what the final transformation is to get figure 2. Okay, so we're going to reflect it. So here's where A prime would be, C prime would be there. And if I do it correctly here, I believe it's 1, 2, 3, 4, 5 away. 1, 2, 3, 4, 5 away. So I believe this is the triangle, like so. So there's, oops, that's not A prime. That's C prime. So C prime, A prime, B prime. Okay? And then from there, you can figure out the transformation to the second one. For B, again, I'm just going to give you a little hint on this one. I'm not going to draw anything on it because I want you to try it yourself, and you can check your answer with the answer key. There is something happening here regarding A prime or A double prime and A. If you notice, they're not in the same location in each quadrant. Okay, so something happened there to spin that around a little bit. Hence, keyword spin, or another word for spin is turn. So you might want to think about that, and then check the sizes out as well. Okay, so there are your notes on transformations. And if you have any questions over anything, feel free. You know, I have hours for assistance Tuesday through Thursday, and if you need any help any other time by appointment. So just let me know how I can best help you through this, and help you get your stuff on track, and you can take your assessment on time.